technique, okay, of observing the terms. Alright? Observing the terms. This is an identity, meaning to say the left hand side is equal to the right hand side. Okay? What do we have on the left hand side? We have negative 2x squared minus 7x plus 3. Okay? On the right hand side, I have a times x minus 2 bracket squared plus b bracket x plus 1 cube plus x cube. Okay? So we want to find out, okay, the value of a and b. Right? If you want to find out the value of a, okay, how would we do it? You can consider comparing the x squared term. Okay, that's one option. But you need to be aware that if you want to compare the x squared term, meaning to say negative 2x squared with this a x squared that comes out, there are x squared terms that comes out over here. Okay? Because when you expand the x plus 1 to the power of 3, your highest power it goes to will be x cubed. Okay? But there will also be x squared terms coming out of it. So it is not very wise for you to go and try to compare x squared term. Okay? To figure out the value of a. Okay? Because there are x squared terms that come out of here. Right? So we are trying to imagine the expansion without doing the expansion. Okay? Highest power over here will power of 3, then you get lower powers of x as well. Right? So not efficient to compare x squared term. Okay, then how? Right? You could consider maybe, okay, comparing the constant term. It will be easier. Okay, but maybe before finding out the value of a, I find that finding the value of b first easier. Okay, without doing expansion, my goal is to do without expansion. Why is it that I want to find the value of b first? Okay, I see where b is attached to. B is attached to this x plus 1 cube. Okay, when I expand this, x plus 1 cube means x plus 1 times x plus 1 times x plus 1. Okay, in this expansion itself, I will do this first. Okay, later on then when I expand already, I will then do this x again. Alright? Are we able to imagine it? Okay, requires that observation skill. Right? So over here, I'm able to get a bx cube. Okay, and I can only have bx cube. I will not be able to have any other x cube. I cannot have a 2x cube, 3x cube, or anything else. Okay, I will only be able to have a bx cube because x times x times x give me an x cube. Later on, times the b, I will get a bx cube. Okay, then after that, over here I also have an x cube, but over here there's no x cube. So what this tells me is that, okay, the coefficient of x cube on the left hand side will be 0. On the right hand side, it will be b plus 1. Okay? Okay, so therefore, our b will be equal to negative 1. Right? Yes. b, what?
B plus 1, 0 equals b plus 1.
Oh, how I get b plus 1? Okay. So over here, I'm able to achieve a bx cube term. Down here, I also got a plus x cube, which is a plus 1x cube. So, if I were to factorize out the x cube, okay, it will mean that it is a b plus 1 x cube. So by comparing coefficient, down here don't have an x cube term, which means that coefficient is 0. But over here, my coefficient x cube will be b plus 1. So that's why they are going to be equal. Okay? So I'm not trying to do any expansion at all. Of course, if you find that it is difficult for you to do that level of observation, then by all means go expand. Okay, not going to stop you. But it will be very challenging because what if I give you a power of 4, power of 5? Okay, you expand until no tomorrow. Then by no means already is. Yeah. Okay, so that's another method. Okay, so one method is by observing, okay, the expansion and then on that compare coefficient. So the other method is to substitute in suitable values. Okay, so if you want to by substituting suitable values, right? Okay, if let's say I'm trying to find out what's b, I want to get rid of this 2. Okay, so you can get rid of this a to be considered by letting x to be equals to 2. So once x is equals to 2, down here will be 0 already. You don't need to go and think about a anymore. Okay, so another method, choose suitable values, let x to be equals to 2. Then on the left hand side, it will be this. And then on the right hand side, we will get a times 0 plus b times 2 plus 1 cube plus 2 cube. Okay, so a is out of the discussion. I will have my 3 power 3 27 b plus 8. Then over here, negative 8 minus 14 plus 3. So negative 22 plus 3, which is negative 19. So this is a b. Okay, so can do by substituting suitable values as well. Right? Okay, so do what is actually easier for you. I will encourage you to actually know how to do by substitution of suitable values. Because later on, once we reach the end of this chapter, partial fractions, this will be a more useful skill. Right? But building up your observation skill is also very helpful. Okay? Right, so if you want to do by comparison still for your finding the value of a, okay, what you can do is I would choose to compare constant term, it will be easier. Because I will know negative 2 times negative 2 and then later on with the a, so I'm able to get the positive for a. Over here, 1 times 1 times 1, that will give me a 1, so I'm able to get a b. So I can say that 3 equals 4a plus b. Okay, so finding out the value of b already, I will have 4a minus 1. So 4a equals to 3 plus 1 is 4. a equals to 1. Okay. Right, so this is by comparing. Okay, I compare constant term. Because down here the constant term is 3. Okay. Over here in this expansion, negative 2 times negative 2 is positive 4. Then times the a, you get positive 4a. Yeah. But over here, constant term is only generated when you have 1 times 1 times 1. Okay. And that will give us 1 times b, so 1b. Okay. So therefore, the constant term that is out of in this expansion will be just 4a plus b, which is compared to the constant term 3. So they got to be equal. Okay. So it's really about your strategy now. Okay. What is it that you do? Alright, so if you want to use the same method for solving your finding the value of a by using substitution of suitable values, okay, what you could do is let x to be equals to negative 1. Okay, why do I let x to be negative 1? It is to create a 0 over here because negative 1 plus 1 is 0. So doing the substitution, a negative 3 squared plus 0 plus negative 1. So I will get negative 2 plus 7 times 3 plus 9a minus 1. 5 plus 3, 8. So a is equals to 1. Okay. value of b, correct? Because you already found the value of b, it really doesn't matter, okay, what you want to substitute as, okay, because whatever number that you substitute in, you're only going to find out the value of a, since you already have the value of b, okay? Just that when you substitute in x equals to negative 1, okay, you can ignore entirely what is the value of b, right? So in fact, I would have chosen to substitute in x equals to negative 1 because in case my value of b is wrong, okay, then at least it will not affect my accuracy in my answer for finding the value of a. Because if I substitute something for x, right, that is not negative 1, there's something else like what Alex has chosen 0, right? Okay, I need to ensure that my value of b is correct. You understand? You all get what I'm trying to say? Okay, so let's say if I want to let x to be 0, down here everything is 0, then left 3. Okay, when I let x equals to 0, I'm actually getting 3 equals to 4a plus b. I need to ensure that my b is correct in the first place in order to find out the value of a. Okay, if my b is wrong, then your value of a will be wrong also. Okay, and then you lose 4 marks from there instead. Okay, so it's just a strategy lah. Okay, to safeguard yourselves. Questions? Right? Then for question, hang on, 10a. Okay. May I know what's the concern for 10a?
I think I can solve
You
it.
think you can solve it already? Okay. Then how about 10c? Okay, I will ask for 10c. You ask for 10c, right? Oh, ready? 10c? No, may I know, do you think you are able to solve already? No? What would you have done? After I went through this already, what would you have done looking at 10a? Substitute, can you try it? Okay. Okay, next we look at question 16. What's the challenge for 16? May I know? What's the problem in terms of doing 16? Question 16. Ask for question 16. So what's the issue? Don't mind just share so that oh, so the long division process can. Okay. So let's go. Okay. Likely, I guess it's because the divisor is actually 3 terms. So to do the long division, you just need to be very careful at division. Okay. On top here, we will choose 2x cubed. So that multiply with x squared, I will get 2x to power 5. Okay. Followed by minus away 2x to power 4, minus away 4x. Okay. So I'm getting this. Right? Notice that my terms are not aligned. Okay? I don't have an x power 4 term over here. Okay? So if you want to ensure that the way you do is or rather you want to build your skill in your long division, okay, maybe you want to align your terms first. So let me just negative x cubed. So you can align it in this manner. Power of 5, then power of 4 don't have, right? Okay. Power of 3. Okay. Next start. Okay. we will plus 2x squared minus away 2x cubed minus away 4x squared. Okay, so x power 4 term is address, plus 3 minus negative 2, that's a plus 2, so 5x cubed plus 4 5x squared minus 4. Okay, then continue again. 5x, so 5x cubed minus away 5x squared minus 10x. Oh wait, I realized I forgot about x how much. Plus 10x squared plus 10x minus 4, then plus 10 minus 20. So we get 20x plus minus 4 plus 20 minus 6. Wait. Minus 4 plus 20 minus 6. Alright? Did I make any mistakes? Okay. It's important that you don't just focus on copying what I've written, but you also go through the whole long division process itself. Okay, so the answer will be 20x plus 16. The question wants you to find the value of a. So a equals 20, b equals 16. You don't know what is QX. So to try to actually do your expansion method, it will not work. Okay, because you cannot do any form of expansion since you don't have this polynomial QX over here. Okay, you can only rely on one method, that is by substituting suitable values. Okay, so we will need to substitute in x to be equals to 2, so that over here is 0. 0 times this polynomial, it will be 0 already. Okay, so that's why we sub in x to be equals to 2. Otherwise, okay, if you want to do division, long division, you can, that's another way. Okay, but actually you may realize that doing long division Technically, yes. Yeah, I didn't think about it that way because I didn't see how. Let me see. What if we do by substitution? Okay, I'll just do by substitution first, then I proceed from there. I'll show you another method. So, times 4 minus 4 plus 1. 32 minus 24 plus 1 is what? 9. We get A to be equals to 6, right? We get that? Okay. Let's challenge ourselves. How can I find QX without doing long division? So I found A to be equals to 6 already. Alright? Okay? My challenge to us is how can I find QX without doing long division? Okay? So remember I mentioned that this is a degree what polynomial? 3, right? And this one is degree what? 1. So QX should be degree what? It should be a degree 2. Alright? So if you want to do this without doing long division, okay, what you can do, knowing that it is a degree 2 polynomial, okay, a degree 2 polynomial means that it is quadratic. Quadratic has a certain format to it, okay, you can do ax squared plus bx plus c. Let that polynomial be ax squared plus bx plus c. Okay, then after that plus 6x minus 3. Okay, then what you need to do next is to determine what is the value of a, b, and c. Okay, to determine the value of a is easy actually, because we know that in order to get a 4x cubed term, it will have to be x times ax squared. So your a will have to be 4. So comparing x cubed term, 4 is equals to a, because x times ax squared. Okay? Right? Then to get the value of b, okay, if you want to compare the coefficient of x squared, okay, that requires a little bit of being careful. Down here on the left, it is negative 6 for the coefficient. On the right, in order to get the x squared term, it will have to be negative 2 with ax squared. What other multiplication will I get x squared term? X and bx. Okay, maybe I'll choose another color so that we can see it easily. Okay, so therefore, negative 2 times a, you get negative 2a. Then after that, down here the coefficient is 1 times b, so you just be b. Since we already found the value of a, okay, we find that b will be equals to 2. Right? Then to compare the constant term, I'm just sticking to just comparison. Yeah. No what? Plus 6. This one x squared term. 6 is a x term, power 1. Okay. Then comparing constant term, on the left hand side it will be a value of 1. Okay. On the right hand side, constant term is only possible when negative 2 times c. And that is negative 2c. Then not forgetting the minus 3. Okay? So we will get 1 plus 3 equals to negative 2c. 4 divided by negative 2, you will get negative. Okay? So our quotient would be 4x squared plus 2x minus 2. Okay? So this is just another method that you can do without doing long division. Nothing wrong. Okay? Doesn't make sense? Because you'll be answering part 2. Wait, 4x squared divided. Okay, yeah, any substitution, yeah. Correct. Oh, okay. Yeah, so it's not working backwards, right? Yeah, that was my okay. Yeah. Okay, I didn't try the long division part. Alright, so looking at what they have just done, okay, I realized that the long division didn't quite work out because it doesn't go with the usual rules that we follow. Yes, I did. Okay, I think I said I'll ask a good question. When do we know when to sub in and when do we know when to compare? Okay, actually either methods will work. Yeah, you can do by substituting suitable values also. But the problem about substituting suitable values is that sometimes you get more than one unknown. Okay, because if you decide to sub in x equals to 2, for example, then all your unknown a, b, c gone already. Disappears, right? Okay, then if you were to, let's say, substitute in x to be equals to 0, okay, once x equals to 0, down here will be 0, down here will be 0, you can find out the value of c easily. Yeah, so the whole idea about substitution is that we're trying to remove certain constants to facilitate our calculation. Okay, so maybe that is a principle that you can write on okay, when doing substitution. Right, you want to create zeros so that you can ignore some of the unknowns. Okay? Questions? Right? We will write on this skill a lot more when we hit partial fractions. I think that's chapter 4.5 or 4.4. Okay? Yeah. Right? When did I get the what? This thing? Because quadratic what? Degree 2 So highest power must be 2. Then I assume that there is a power of 1. Okay, then constant term going downwards in decreasing powers. You cannot say that there is none of it. Yeah, because if there's none, automatically when you calculate it will become 0. Yeah, for you. So you must assume all are present. So you go in increasing powers effects. Okay. Yeah. Why is it just in terms of px squared plus so I compare a is 4 because I calculate a is 4. But then after that b I calculate this is supposed to be my qx. That's why my qx is this. Yeah. So in your corrections, you need to copy entirely everything. Okay, you cannot just copy from here. Yeah, because this part are critical to help you understand why we're doing this. Okay. Now,
How do we know that one is degree?
how do I know that's degree 2? Because remember when we did long division, we covered that concept. If this one is degree 3 and this one is degree 1, the degree of this and the degree of this must add up give us degree of this. Yeah. So I know this is 2 because 3 minus 1 is 2. Okay? Yeah. And this must be degree 2 because in our expansion, I must have the x cube term coming out from here in order to get this. Down here surely will not have the x cube anymore. Yeah, so to get the x cube over here, it must be x times the x squared. Yeah. Okay, just that we don't know what is the coefficient of the x squared now. That's why the x squared.
But I don't understand how you compare the terms to like the.
So it's about your rainbow method. Yeah, knowing how to multiply to get the things. So x cube term, I must be getting x times ax squared 1. X times anything else will never have x cube term in it.
So you want to find that specific term.
I want to find a specific term.
Then the coefficient of that term.
Will be equal to okay. So I don't bother in expanding the whole thing. I just focus on what I want. Yes.
So if I derive from the set maybe of ax squared plus bx, then if I want to sub in the value, it doesn't matter what I find first, right?
Doesn't matter. You don't need to go in the alphabetical order. Yeah. Okay. Right. Maybe with that, we accept this idea first. Okay. We will go back into this when we go into partial fraction. Okay. Don't let this hinder yourself now. Alright. We just do what we can with this first. Partial fractions will be easily okay. Okay. Right. If you're okay, then can you pass down your homework to the front. Okay, so yesterday, let's look at chapter 4.2 now. Okay, yesterday we have learned what is the remainder theorem and what is the factor theorem. Remainder theorem essentially we sub in a suitable value into the polynomial that we have, we will be able to get the remainder. Okay, for factor theorem, we want to determine whether something is a factor or not. Okay, and that is by substituting a suitable value as well. Okay, whereby the factor is equals to 0. Okay, we find the value of x, we sub in. If the remainder is 0, then it will be considered a factor. Okay, so that was what we covered in remainder and factor theorem yesterday. Today I want us to look at try 13. The expression ax cubed plus bx squared minus 10x plus 8 is exactly divisible by x squared plus x minus 2. First of all, what does exactly divisible mean? Okay, it means that there's no remainder. It means that x squared plus x minus 2 is a factor. Okay, factor of what? Factor of the dividend. Okay, so they are similar in meaning, right? So you must know what is exactly divisible, right? Now, by knowing that it is exactly divisible, okay, what we learned is that the remainder will become 0, okay, upon substituting a suitable x value, right? But in this case, we have x squared plus x minus 2. It is not linear. Earlier on, okay, all the factors that we're looking at are things like x plus 2, x minus 2, x plus 1. They are all highest power is actually 1. So they are all degree 1. And it is linear. Okay? In this case, it is not linear. But you think about it, if let's say I tell you 30 is exactly divisible by 15, Okay? 15 is actually 3 times 5, right? Can I say that 30 is also exactly divisible by 3? Makes sense, right? Can I also say that 30 is exactly divisible by 5? Yes, right? Okay? So I can break out x squared plus x minus 2 into smaller parts, and that is done via factorization. Okay? So when I factorize x squared plus x minus 2, that will be x plus 2 times x minus 1. Do your cross method if you need it. Okay? So we can say that bx cubed plus bx squared minus 10x plus 8 is also divisible by x plus 2 and x minus 1. Right? Because you said 30 divided by 15. Okay, 30 can also be divided by 3, can also be divided by 5. Right? So what this means is that if I want to find out the value of A and B, okay, making use of the first factor x plus 2, I can find the value of x to be negative 2. Okay, and when x equals to negative 2, right, my polynomial, okay, I forgot to define let fx bx squared minus 10x plus 8. Okay, I will be able to get this, which is negative 8a plus 4b plus 20 plus 8. So this remainder itself must be equal to 0 due to the factor theorem. Okay, in other words, I can say that 28 equals to 8a minus 4b. I can divide by 4 across. By making b the subject, 2a minus 7. I get b equals to 2a minus 7. Surely you have to do simultaneous solving. Okay. We do the same for our other factor, x minus 1. Okay, so we have this polynomial fx, 3x cubed minus 5ax squared and so on. Okay, the question says that a and k are non-zero, so later on it might mean that if you get a value of 0, you have to reject it. Okay, the critical part of the question says that fx is a remainder of negative 32a cubed when divided by x plus 2a. Okay, why did I say that this question is abstract? Because it challenges us to be very clear about what is a variable and what is a constant. Okay, this is fx. Your variable is x. So x is the one that can continuously change. Okay, there's no fixed value to it. But a and k, they are the ones that are constant. There is a fixed value to it. Okay, the way that we're doing this and approaching this question, okay, doesn't differ from what we were doing earlier on. So long as we know that the remainder is this and the factor is this, what is the value of x that we need? Okay, because x is the variable. So help us find the value of k for that divisor x plus 2a. We let it to be equals to 0, and we say that x is equals to 2a. So it's not a number that we're dealing with now. Okay, it is abstract, it is algebraic. Okay, so we are substituting x to be 2a. Okay, into our polynomial. A squared, okay. So substitute in, yeah. Oh, sorry, thank you. Thank you. Yeah. And now adjust. Like that, negative 2a. Okay, then now we have to expand. Okay, so be very careful because this is your algebra. Negative 2 cubed, that will be negative 8 times 3, negative 24a cubed. Negative 2 squared, that is positive 4 times negative 5, that will give us negative 20a. Okay, then negative 2 and k, so negative 2k, a cubed, and 4a. Simplifying it, I will be able to have negative 24 minus 20 plus 4, that will give us negative 40. So because the question says that the remainder is negative 32a cubed, I will be able to equate this to negative 32a cubed. Okay. Then bringing over the 40a cubed, I will get 8a cubed here. Okay. This is where I want us to remember, I have mentioned before, I cannot divide by an unknown on both sides of the equation. So I cannot, let's say, divide a on both sides. Okay, I cannot divide a cubed on both sides in this case. But in this particular question, I can. Why? It's not about a being a constant, it is about the fact that a is non-zero. So the reason why I cannot divide by an unknown on both sides is because if my unknown is a 0, okay, then it cannot work because I cannot divide by 0. Right? But because the question has already facilitated it by saying that it is non-zero, I can, okay, divide a cubed on both sides. Okay? So we need to be conceptually clear. Okay, I divided by a cubed on both sides since a is a non-zero constant. explain it, but I thought that for note-taking purposes, you may want to remind yourself about it. Okay? That's why we divided A for both sides. And hence our K will be equals to A divided by negative 2, and that's negative 4. With the amount of heat that we are facing, okay, and also looking at the time, I don't think I want to leave us with part 2 because part 2 requires deep factorization understanding. So maybe I'll come back to part 2 in the next lesson, right? Unfortunately, I have to assign you homework, okay? Exercise 4.2, please do question 3, 5, 9, hang on, 14, 16, 17, 19.
Everyone. Oh.
Okay lah, this one I did like.
Oh, sorry.
I think it's 16. Wait. Find the possible values of